This is for year 11 methods, exercise 3K, question 7, 10, and 14. So for question 7a, we're asked to find the equation of this graph. Now, what do we know? We know there's the x-intercept at 4 and y-intercept at 0, 5. Now, based on the symmetry properties of a quadratic, we know the distance between here and here has to be the same from here to here. So if this is 4 to the positive direction, this must be 4 to the negative direction, so that must be negative 4. So our other x-intercept would be negative 4, 0. Remember, when solving these equations, we can have 3 different forms to use. One is the polynomial form, x squared plus bx plus c. The turning point form, a x minus b squared plus c, or the factor form, a x minus b, x minus c. Now, the factor form is easy to use if we can use it. Can we use it? We have the two x-intercepts, which is what we have. So we have b and c. So if I use the factor form, we've got y equals a. We don't know what a is, but we know the x-intercepts, minus 4 and x plus 4. When you use the null factor law on that, set that to equal 0, we still get our x-intercepts or solutions being 4 and negative 4, which is what our graph says. Now, to get our a value, we just sub in 0, 5, our y-intercept, into the equation. So 5 equals a, so x equals 0, so we've got negative 4 and positive 4. So negative 16a equals 5. So a equals 5 on negative 16. So that's negative 5 on 16. So therefore our equation would be y equals negative 5 on 16, x minus 4, x plus 4. And we're done. For part D, so I'll go right over here. What information we're given? We're given two x-intercepts and a point. So two x-intercepts and another point. So let's write down our points now. So x-intercepts are 1, 0 and 3, 0. And our other point is our y-intercept, which is 0, 3. So it's a similar process. We choose the factor form because what information will be given can fit into this model. So I'll write what we know first. We know one of the x-intercepts is at 1 and one of the x-intercepts at 3. We sub in the y-intercept and we get 3 equals, so x is 0, negative 1, negative 3. So 3a equals 3, a equals 1. So therefore our equation would be x minus 1, x minus 3. And we're done. Okay. And also, it's good to always check your final equation to see if it matches. So for part A, we've got a negative here. So our resultant x value, that's a minus 4 by the way, our x squared term will be negative. So we should have a negative quadratic. And indeed, we have a negative quadratic. It looks like that. While on the other one, we have a positive quadratic, because when we expand this, the x squared term will be positive. So we have a smiley face, which is correct. Okay, for question 10, we're given a turning point and a y-intercept. So if we look at our three models, it'd be wise to use the turning point model because we're given the turning point form. Okay, so y equals a x minus b squared plus c. Our turning point's at negative 3 and 3, so I can sub in what we know. So our turning point's at negative 1, so negative 1 for the x coordinate, so it's shifted 1 to the left, so therefore that has to be plus 1 squared, and it's been moved up 3. Okay. Now we've got another piece of information, y-intercept's 4, so we sub in 0, 4 into the equation. Remember, the y-intercept equals 0, x equals 0, So 4 equals a x, well x is 0, so it's 1 squared plus 3. So a equals 1. So therefore your equation would be x plus 1 all squared plus 3. And that's your answer to question 10. Also, do a check. If you expand that, the x squared term will be positive. So the parabola will have that shape instead of that upside down shape. We don't have a graph to reference this with, so it doesn't matter. But if there was a graph, it's always good to check whether your equation matches the graph. For question 14, I'll enlarge it. We've got which of the following curves could most likely be defined by the following. Okay, so for the first curve, we've got factor form. So a third, x plus 4, and 8 minus x. So if you use the null factor law, you get x-intercepts at -4, 0 and 8, 0. Now let's look at the graphs and it's what type of graph. It's a positive or negative. It's a negative graph, because if I expand this, I get a negative x squared term. So the shape will look something like that. Okay, so we can automatically eliminate the positive shapes, so it can't be that or that. So it has to be either this one or that one. So we look for the graphs of the x-intercepts of -4 and 8. -4 and 8? No, that's not it either. -4 and 8. This looks more promising. So it's most likely C. So this would match with 4A. Now, we won't do B yet, because that's in polynomial form, and that's probably the hardest form to find out find the equation of that without, making it a turning point form or something like that. So we'll go straight to part C. Part C, we got it in turning point form. The turning point would be at 1, -10. And it's a positive quadratic. So it will either be this one or this one. So looking at our turning point, 1, -10, it would most likely be this one. So this would be the answer to 14C. So it matches 14C. For part D, we've got it in, it's not quite factor form, but we can change it to factor form. Because what do we have here? We got dots. So I can I can factorize that further to go 3 minus x, 3 plus x. So our x-intercepts are at 3 and -3, 0. And this is a negative quadratic, because if you expand that x squared term is still negative. Okay, so now let's look at it. It's negative quadratic, so it's either this one we're going to use. So by process of elimination, it must be that one. Let's check our x-intercepts, whether it's 3 and -3. Yep, that looks pretty close. So it's most likely 14C here. So by the process of elimination, this must be 14B. 14B.